Okay, cool. I think that is recording now.
Gonna make Google proselytism. I should know that one.
Proselytism means that I'm trying to convert you.
Right, that's okay. Great.
So yeah, I'm trying to convert people to the open source way of life. Um, yeah, so this is partly I partly wrote this for YouTube and then also partly for my partner's biology lab. So some of this may be redundant, like I don't need to convince you to use Git because our lab already does, whereas they might need some more convincing. So this is the general outline. So first I'll talk about what Git actually is. And then, so this will be mostly me talking, and then the second part will be more interactive, you guys setting up repos and stuff. Okay, so what is Git? So there are two terms that I'll use and that you might have heard. One is Git and one is GitHub. Git is it's a command line utility and it's used for version control. So it has a bunch of tools for making different versions of your code, different branches of it. You can track changes between different versions and do all sorts of stuff on the command line. That's what the logo of Git is. This is like code branching into two different versions. So Git's all about local version control, and all the commands we'll run later are all Git command line commands. And then GitHub is a website. It has a bunch of tools, so you can visualize the different versions and the changes between versions. And then also GitHub's other big powers that allow you to collaborate a lot more easily. So a bunch of different people can contribute to the same code base on GitHub. So there are a bunch of benefits to using Git. These are some of them. So the first thing, it's effectively impossible to accidentally delete code, which is quite useful, right? Like if I have a bunch of code that I'm running on the Supernode machine and I misclick and delete stuff, that can be bad. But if it's on GitHub, then you're totally fine. It's all backed up. So just to prove that, this is a nice demonstration. Okay, so I have my GitHub directory. I'll go into the pipeline. Okay, there are all these files in the pipeline. Here are all the Python scripts that we wrote. Okay, so there are 34 different Python scripts in the pipeline. In total, the pipeline is 13,000 lines of code. Okay, and it's been written by like a dozen different people over the last like almost decade. Okay, obviously, we all know very integral to everything we do. But if my fingers accidentally slip and I accidentally import the whole directory, that's totally fine. Now all of my code's back. Okay, so impossible to delete stuff. So that's one very useful thing about it. The other thing is just to walk through some GitHub repos to show you some stuff. So here's the GitHub repo for the pipeline. You can see the pipeline has been updated 818 different times by like a dozen different people. Each time it gets updated, that update gets tagged with a date or with a date and a time, and then you can go and see what changes got made. So Azalee made this change like a month ago. She deleted some lines, she added some lines. You can see all that. You can go see a history of everything that's been changed and when that all happened and who did it. For each file, if you open up the file, you can see the last time the file got updated and who has updated the file. If you go over to this blame tab, then for each line of each file, it tells you who wrote that line, when that line got written, what else got changed when that line got updated. So that if this line starts throwing some errors, then you can go and say, Jamie wrote that line, so let's go ask him what's going on. For larger collaborations, so if I go to the GitHub for AstroPi, so AstroPi has been updated 30,000 times by like 400 different people. It's used by 24,000 other people. So this kind of large collaboration would just be like totally impossible to keep track of all this stuff without GitHub. And then GitHub has other tools. It has this issues tab. So if people are using your code and they run into some bug or something weird happens, they can open an issue and say, I got this problem, here's what I ran, here's what the bug looked like. If people have features that they want to add or bugs that they want to fix, they can do that with a pull request. So this person made a bunch of changes and they can write what things they were trying to fix, and GitHub tracks all the changes that they made. So it allows collaboration like that. So yeah, GitHub has a bunch of advantages. These are just some of the things I listed. I think it is like, it's just insanely broadly useful. So I think it makes you a better programmer. I feel like scientists have a tendency to like write bad code and then hide their shame away. But if you write code and then you put it on a website that anybody can read, then you'll like, that'll make you write better code, knowing that other people will read it. I think it also makes you a better scientist. Like for my upcoming paper on the early type 1a supernova sample, I'm like integrating a Git repo with it. So for all of the results that I get, I'm going to say, if you want to reproduce this, go to this repo and here's the script where you can see how I made these measurements. Here's the command to reproduce my results. So yeah, I think it makes you a better programmer, better scientist. It just has a bunch of benefits. Okay, so that's enough of me rambling. So we'll do some account setup. So first, if you don't already have a GitHub account, then you should get one. So here are the steps to get one. Craig, I know you already have one. SD, I think you already have one. Megan, I don't know if you do.
I do. I haven't logged in a while, so I'm going to figure out that combo real quick.
All right, sounds good.
It just told me your password is in a list of passwords commonly used on other websites. So that's great.
Is your password a password?
No, it's an older password, and so I kind of already knew. It's one I've like gotten emails before, like a good couple years ago, saying that it was likely involved in some breaches. So I've changed most, but that goes to show, like, wow, it really is out there then. So
yeah, I'm logged in.
Okay, cool. And yeah, like I also said, you should remember your username and password email, because we're going to use that in a second.
part of it is this account for me was from my undergrad email, and it should be easy enough to transfer that, right? I mean, just to update the email, or maybe would I have to make a whole new account? Because that email is going to be obsolete soon.
Yeah, I would probably just make a new account.
Do that. Okay. Except username Megan Newsom is not available. Dr. Megan Newsom it is. It made me choose like a spiral galaxy and like the CAPTCHA thing. That like I probably most people using GitHub would be able to do that, but still I was like, geez, that's anyway. Okay, I'm on. So
Okay, sweet. Ah, man. Okay, so next you should test that Git is working on the command line. So I have a directory where all my Git repos are stored. A repo, which is a word I probably should have already defined, is just like a project, a self-contained project code base in GitHub. So I have a home GitHub directory. So I would recommend making one, although of course you don't have to, and then you should test if Git is working by running this command. Okay, thumbs up from Megan, good. Craig, I assume Git is working for you because you use it.
I know mine also works because I use Git to install TARDIS, so it's like Git clone.
Okay, nice, good. Yeah, I wanted to have the slide because if you upgrade your Mac to Big Sur, then you have to do this thing. It's like not hard, but you just have to do an extra thing to get it working. So I just wanted to make sure that it was working for everyone. Sounds like it is, so good. So then you should link your Git and GitHub profiles. So here, use the commands to do that.
so sorry, what is this step doing? Is it like just setting kind of things on my end?
Yeah, so this is when you use Git to interact with GitHub, then Git will already know what account to associate itself with. So yeah, this username and then the email should be your GitHub username and email. And then the last thing is just to make sure that the colors look nice, because that's important.
Do you have to do anything before the first command, the git config global? Because whenever I run it, it just says key does not contain a section. Estefania Padilla. Because wait, do we have to put our actual username and user.name, right? Because that's what I did.
Yes, yeah. So like my Git username is jfrostberg, so I do git config global user.name quotation marks jfrostberg quotation marks.
Okay. Let me try again.
Craig, I see a look of consternation. Is the same thing happening to you?
No, sorry, I'm doing Snexu stuff right now. Sorry.
It's
Consternation is next.
pay attention. No, that's fine.
Dang. Hopefully this works. Okay. Okay. So nothing should return, right? Whenever I did it, we just
Yeah, I don't think it'll say anything.
okay. Okay.
Megan, are you good? Did it work for
Good.
you?
Mine worked fine. Yeah.
Okay, cool.
Yeah, mine is working also.
All right, good
Like
stuff.
nothing returned, so
Cool. So we got all that set up. Good. Yay.
Haven't you heard that emojis are out? I'm just kidding. Fake
Yeah.
Gen Z millennial humor.
So the rest of this will be setting up your first repo. I am not sure how long this will take. It might be over very quickly. I have ideas for extended things, but yeah, see if I judged how well I judge the time at all. Okay, so for your first repo, your first project, go to your GitHub directory and then make a new directory and move into it, or CD into it. And then using whatever text editor you prefer, make a text file called readme.txt. The name is kind of important. Calling something readme means that Git displays it more easily. Whatever you put in the README is less important, but that's what I suggest. Okay.
wait, so we just put my favorite planet is Mars.
Yeah.
Okay.
And then let me know whenever you're done.
Okay, I'm done.
Sweet. Okay, so then do git init space period. This is a command that tells Git to initialize the current directory as a repository. So then once you run this command, it should say something, and then if you do ls space -a, A stands for all, so it'll show hidden files and directories as well, then you should see a new .git directory. That just means that Git knows that the current directory is a repo, and it'll store the history of it there. And then if you do git status, it should also say something like, it's a repo and you've added some files or whatever.
Okay. Yeah, mine just says on branch master, no commits yet. Nothing added to commit, but on track files present.
Okay, yep, that sounds about right. Okay, cool. So next, switch back over to GitHub, your browser. And then you've made a repo on your machine, on your local machine, and then we have to also make a repo on GitHub and then associate them. So these are the steps for making a repo on GitHub. You just go there, click some buttons, name it, and then make a repository.
And good.
Sorry, it made me verify my email first, but we're good now.
Okay, cool. Okay, so we have our local repository and we have our remote repository. So the next step is to link them. So back on the command line, do this command, git remote add origin, and then the URL that you just made.
Is that to say replace the URL with the URL, right?
Yeah.
Oh, your line below literally says that. Sorry.
Indeed.
Going too fast.
Okay. Yeah. Is it origin and then the link fetch and then push?
So yeah, do this, and then if you
Mhm.
do git remote space -v for both, then it should list like origin is linked to this.
Mhm.
So yeah, just an explanation of what this command does. So this says, we're using git, we're going to add a remote repository. So we're going to add, there's a distinction between your local code, your local repository, and the remote repository on GitHub. So we're adding a remote repository, we're linking something to GitHub. The name of that is going to be origin. Origin's like the normal thing that Git users call their like default remote repository, and then you have to link it to the right URL. Okay, cool. So now when you did git status, it should have said, you know, this is a repository, you don't have any commits yet, and you have this one untracked file. So add that file, and then git commit, and M stands for message. So every time you make a commit, you make a change to your code, you should put some helpful message here. So I just said, this is the initial commit. And then git push origin master. So you're pushing your local repo to the remote repo, which is named origin for shorthand. And then master is what branch you're pushing, what version of the code you're pushing. And the default branch is always called master. So once you do this, it might ask you to input your GitHub password. And then if you go to the GitHub page and refresh it, then you should see that you just updated you just added a README and it says Mars is my favorite planet, or whatever you put in there. So Megan, that worked for you?
Looks like it.
And what's your GitHub name?
Dr. Megan Newsom. Now I gotta fulfill it.
Yeah, now you gotta become a doctor. Cool. Wow, look at this cool repo. Favorite planet is Jupiter? Weird.
It's not Mars. Choose something else.
And then
Totally
Esty,
fair.
did this work for you?
Yeah.
Cool. And what's your Git name?
Estefania Padilla.
Sweet.
My name wasn't taken.
My name was taken by me and my other account, so that's frustrating. I'll fix that eventually. I just don't want to do it all right now while we're just practicing. So
Yeah, it's all good.
Yeah, for me, even if my name was taken, I just keep adding my last name. So
yeah, there you go.
Okay, cool. So that was your first commit. So let's do another one. So add a line to your README. You can add whatever you want, although this is, if you don't want to use your brain, you can add that line.
So the only correct statement.
Is your favorite color really purple, or you just?
My favorite color is purple. That's true.
Nice. I've read before that, like, I don't know, like people who have general favorite colors, it's just along the lines of like, yeah, I like blue and yeah, I like red. And then purple lovers are just like kind of remaining children about it a little bit. Like, I need purple everything. I very like that personally. Try not to be, but I am.
Brutal. But yeah, so after you have updated a file in your repo, if you do git status, it should say, you know, you've updated this file or on track changes or something. And then if you do git diff, then it should list what changes you made since the last time you pushed a commit. So it should just say, you know, like plus my favorite color is purple, whatever. So then do the same thing you did last time. So add the file, commit your change, and then push your change so you can see it on GitHub.
Wait, what does git diff mean or do?
So git diff, if you don't do these steps yet, git diff shows you the changes you made
Oh, okay.
from now and your last commit. So it should just say that you added a line.
Mhm. Okay, cool. Thank you.
And then let me know whenever people are done.
I think mine's full.
All right, cool. So just an explanation of what we've done, because this is the basic Git workflow. We have our local repository, the code that's actually on our computers. We're in our working directory. We edit a bunch of files for a project. We might just edit one line of one file, or we might add 1,000 lines in 20 different files, whatever. Once we're done editing stuff, then we add the changes that we've made. We add the files that we changed to like what I think of as like a staging area.
Mhm.
So whatever files you change that you want to preserve those changes, you add those files. Once you've added all the files you want, then you commit those changes, and that updates your local repo. And then you have to push those changes to GitHub, to the remote repo, to make sure that they're accessible on GitHub. You can just do like this part of it. You can just update and work stuff locally, but especially if you're collaborating in code, then you should remember to push the changes to the remote repo. So this is the basic workflow. You edit stuff, you add the files, you make a commit, and then you push the commit.
I have a question. Is there a way to just go from adding to pushing the changes, like without committing first? Is it committing like in case, like for example, like you delete something, so then it's kind of like saved there on the commit? Is that why we need that stage?
Yes, there's a
Mhm.
separate command. If you remove a file, you can do git rm file name, and it'll remove the file from your repository. You can also do, I think it's git commit -a or -A, I forget, and that'll automatically add all the files that you've changed into your commit. But yeah, a commit is saying like, this is a discrete, definite change that I've made to the code. Like I updated this algorithm, or like I added this comment, or like made some change. Okay, cool. So do the git workflow again, make some other change to your repo, and follow the workflow and push that change to your remote repo.
All done.
Nice.
Almost.
Favorite dog is Johnny. Great choice. Great choice.
I couldn't possibly let him think it was another dog, even if that were true.
When he goes and checks your repo, you want him to know. Favorite food is tacos. Great choice.
Great choice.
Great choice.
Great choice.
Yeah, so this is the point of doing multiple commits, and then also adding a helpful message each time, so that if you want to say, oh, when I updated that one file and like I made this change, what did I do? And then you can go and see, oh, this is the thing where I added my favorite food. Cool. So now if you're in your browser and you do git log, then you'll be able to see your commit history. So oops. So if I do git log, then these are the 3 commits that I have made. For each commit, it tells you who wrote it, the exact time that you did it, your commit message, and then they also have these hashes. So these are randomly generated, and they're distinct ways that Git uses to identify different commits. And then, like I say here, if you do git diff, the current place or the most recent commit is always called head. So if I do git diff head -1, then that's the difference between my current place and the commit before that. It's like, I think of this tilde as like a minus, git diff head -1. So the most recent change, or the difference between the current place and the last commit is that I changed my favorite planet. The difference between the current place, the head, and 2 commits ago is I changed my favorite planet, and then also added my favorite commit. So you can use this to track the changes between different commits. You can use this to reset to an earlier commit, although Git makes that kind of hard. Okay, so that's pretty much all I have for this. Like I said, I have lots of ideas for future things, like we can make different branches and PRs. But I thought this was a good place to stop for like an initial familiarization.
Yeah, thank you. Like I mentioned, I mean, my computational astro class went through it all before, but that was a good 2017, however many years ago, we won't speak into existence that was. So, and that one used Bitbucket, which doesn't seem to be that different in terms of like structure of what you're writing and stuff, but so it's just worth to be refreshed that on the Git stuff. So that's good. Thank you.
Yeah, thank you so much for putting this together. It was a really nice presentation, very clear, and then even the exercises were like fun and easy to implement. So thank you for your time.
Yeah, and the flowchart where you were like edit, add, commit, and everything. I don't know. It seemed so obvious when she said it, but it was one of those things that had you not said that, I would have just been doing what instructions told me to a little bit and just accepting an end product and without fully. I didn't. It makes sense, but the commit thing happening technically my local repo makes sense, but I would not have thought. I thought that was something happening with GitHub website, all along. So like it's cool to kind of really get that all more organized in my brain. So yeah.
Yeah, this was like 90% copied from a tutorial that Esley made. So shout outs to her for making that diagram. Because yeah, I saw that and I was like, oh yeah, that is really helpful. And like that's the like core Git workflow.
Yeah. Well, awesome. Thank you. Are you planning on doing more of these? Do you want to? Because you're already doing a lot.
Yes, I do want to do future ones. I'm going to stop the recording.